Hello guys, my name is Ishmael. Today we will be doing fractional distillation part 2. So I've made two videos for this only because this is a large topic and there's a lot to get in. And so yes, let's begin. So, now you've probably seen this before. This is the fractionating column. Now you've got to remember each component of the fractionating column. So what I mean by component is each fraction, so the name of the fraction, and in order, so it goes from refinery gas to petrol to naphtha, etc., and so on. And so you also need to know the trends, so you need to know that smaller molecules are at the top, larger molecules are at the bottom. And so I've got a mnemonic that I'll show you later on, which will help you to memorize it. So yes, so the fractionating column is responsible for primary distillation of crude oil. So it does not separate individual hydrocarbons. So after primary distillation comes secondary distillation, which could be used as fuels in the car so that it can remove some of the sulfur, and sulfur is an impurity which can cause pollution. Or another type of secondary distillation would be some of these hydrocarbons. So another type of secondary distillation would be cracking of the hydrocarbons so that they go from long chains to smaller chains, which will be much more useful. Or you can further distill, or you can like further distill the residue. So, looking at the residue from primary distillation, which is the first part of distillation, contains substance that boil over 350 degrees, and this is done at normal atmospheric pressure. Now, the boiling point is really high only because of the length of the hydrocarbon chain, and it takes a lot amount of heat energy just to break those certain chains. So the residue then requires further distillation to obtain the remaining useful fractions, as long hydrocarbon chains are not to any use. So therefore, further distillation is carried out with a reduced pressure. So this is known as vacuum distillation. So any distillation with a reduced pressure is known as vacuum distillation. Now, this vacuum distillation is done straight after primary distillation, and this allows the mixture of hydrocarbons to be separated at different temperatures below its normal boiling point. And so this prevents the components decomposing, as excessive heat can decompose the residue. So it goes from primary distillation. If you still got residue, then it goes into vacuum distillation or secondary distillation, where the pressure is reduced, and so the fractions are separated just below the normal boiling point. So let's look at deeper detail in why fractional distillation works. So different fractions of crude oil have different boiling points. Now we all know that, and they have different boiling points due to the length of hydrocarbon, like I said before. And crude oil mainly consists of aliphatic hydrocarbons, and if you don't know what that is, look that up. But basically, aliphatic hydrocarbons is straight or branch chained hydrocarbons, but you should know what that means. If you don't, then you should slightly worry, only because you need to know a lot of definitions to make your life easy for the exam. So, as we carry on, in the shorter chain hydrocarbons have weak van der Waals forces between neighboring molecules, therefore not much energy is required to break these van der Waals forces. So the shorter the hydrocarbon chain, the lower the boiling point. So whereas longer aliphatic hydrocarbons have stronger van der Waals forces between neighboring molecules, therefore more energy is required to break these forces, and so they will condense nearer the bottom of the fraction and will have a higher boiling point. So, just a little bit more extra information. So, majority of the fractions are used for fuels, and but the downside to using this as a fuel is that it is a finite energy resource, so it's non-renewable. You won't have so much of it. So as more is used, supplies become more limited, so more fractions may become too valuable to burn. So some fractions are further refined via cracking, which we will look at later on, to make smaller and more useful molecules which may be branch. So saturated or aromatic is what you would get. So alkenes and aromatics are useful feedstock for the petrochemical industry. These are then turned into more important products such as medicines, so like paracetamol, ibuprofen, dyes, plastic, and detergents. Now, the mnemonic I've got, please do not take offense to it. It is only just there to help you memorize it. And so, yes. Lesbian people never kiss gay men from West Brom. Now, this is how you're going to memorize the fractional fractions in the fractional distillation column. Now, I know it seems a bit crazy to have this mnemonic, but it's kind of funny, but is unique, which is why you can remember it. So, lesbian stands for LPG, people stand for petrol, never stands for naphtha, kiss stands for kerosene, gay stands for gas oil, men stands for mineral oil, from stands for fuel oil, west stands for wax, and brom stands for bitumen. And so, if you memorize that, and then draw an arrow next to it in the exam, so you've got lesbian people never kiss gay men from West Brom, you've got an arrow, and so at the top you can put low boiling point, small hydrocarbon chain, easy to ignite. And if you know just one of them, so one of the trends, for example, the smaller hydrocarbon chain, so if you know the trends for the smaller hydrocarbon chains in the fractional distillation, you can easily work out the ones for the ones with a higher hydrocarbon chain, and so basically it's just the opposite of each other. So please do not take offense to that. It's not there to offend anyone, it's just there to help you memorize. So this is the name of the alkyl group, so methyl, ethyl, propyl, butyl, pentyl, and hexyl. So you just need to memorize this, and it will help you later on in a couple of videos that we'll go through. So methyl, as we looked at before, we know that meth is 1, eth is 2, prop is 3, but is 4, pent is 5, hex is 6. So you'll be able to use this in this further video called nomenclature, but if you memorize it now, it will be much easier later on. And so you can work out the names of each of the hydrocarbons in the fractional distillation column, but for now, let's just memorize this. So you know that methyl contains one carbon atom, which in the branch. Ethyl contains 2 carbon atoms, propyl 3, butyl 4, pentyl 5, hexyl 6. So yes, that's it for today, and if there's any problems or anything I can improve on, or if there's anything good, please do comment it down below. And so yes, in the next video we will look at cracking.